In this lesson, we'll address the concept of standard deviation. To understand standard deviation, let's take a look at the following three sets. The first set is all 10s, 10, 10, 10, 10, 10. The next set, negative 10, 0, 10, 20, 30. And the third set, negative 30, negative 10, 10, 30, 50. Now, thus far, we've looked at several ways to describe sets of data. One way to describe a set of data is by determining the mean of that set of data. Notice if we determine the mean of these three sets, we would arrive at the same value for all three. The mean of every one of these sets is 10. Another way we've looked at to characterize a set of data is the median. And similarly, if we determine the median of all three sets, we would also arrive at the same value. We would arrive at a median of 10. So the mean of all three sets is the same, and the median of all three sets is the same. But there's another element of this story, another way to characterize the data. And that component concerns dispersion. When I say dispersion, what I refer to is a distribution of the numbers in the set. If we take a look at these three sets, what you'll notice is that the numbers in the first set are all very close to one another. In fact, they're not dispersed at all since they're all the same term. Whereas if we look at the numbers in the last set, they're very far apart relative to the other two sets. To characterize the distance of the terms from one another, we're going to use the concept of standard deviation. Now, if you've taken a statistics class, you probably learned some elaborate formula to calculate standard deviation. Fortunately, the GMAT doesn't address the formula for standard deviation, so we're not going to focus on that. Instead, we're going to focus on a way to estimate standard deviation. And that formula will be the following. Standard deviation can be thought of as the average distance of the numbers in a set from the mean. In other words, we want to see, on average, how far apart are the numbers from the average of the set. Now, this will not get us the actual standard deviation, but it'll give us a good estimate for standard deviation, and this approach will serve you well in all standard deviation questions. So to understand how to apply it, let's use this formula on the three different sets in this question. So let's start with this first set. We'll start by determining the distance of each term from the mean. Now, in this first set, we know the mean is 10, so each term here is a distance of 0 away from the mean. Since each term here is 0 away from the mean, the average distance from the mean here is 0, and so the standard deviation of this set is 0. Now, let's look at the second set. We know the mean of the set is 10, so now let's get the distance of each term from the mean, and we'll arrive at distances of 20, 10, 0, 10, and 20. Now, our goal will be to determine the average distance from the mean. To do so, we'll start by adding up the distances, which will come out to 60, and divide by the number of terms, which is 5, and we'll arrive at a value of 12. So an estimate for the standard deviation of this set is 12. Finally, if we look at the third set, we again know the mean is 10, and we know that the terms in order are 40 away from the mean, 20 away, 0 away, 20 away, and 40 away. And again, we're going to calculate the average distance from the mean. And to do so, we'll get the total distance of all the terms from the mean, which comes out to 120, divide by the number of terms, which is 5, and we'll arrive at an estimate of 24 for the standard deviation. Now, a couple important points to emphasize here. Again, these values of 12 and 24 don't actually represent the standard deviation of these sets, but this is all that you would need to do for a question like this, since generally the GMAT will ask you to compare standard deviations instead of actually calculating it. Another important point here is to understand that standard deviation can never be negative. The smallest the standard deviation of a set can be is 0. Why? Because standard deviation measures distance from the mean. You can never have a negative distance, so you can never have a negative standard deviation. Now, oftentimes, GMAT questions will ask you to compare standard deviation to various sets. So an example of a question would be one that asks you to determine which of these three sets has the greatest standard deviation or the least standard deviation. Now, you can always use what we discussed in the previous slide where you calculate the average distance from the mean. But keep in mind that can be time consuming. If we look at these sets, you'd have to sit there, get the average of the whole set, and then get the distance of each term from that average, and then get the average distance of all those terms. So that can be time consuming. So in situations like this, it's instead helpful to often just eyeball the different sets. So let's say we want to determine which of these sets has a greatest standard deviation. Well, if we look at the first set, we'll notice the numbers here are very close to one another. It's a maximum distance of 6, and generally they're all clustered pretty close. So this first set should have a pretty small standard deviation. If we look at the next set, the standard deviation is certainly greater than the first set. Again, we don't know what it is, but it's definitely going up given that the range is definitely greater, and the numbers consecutively are also further away from one another. So we know the second set will have a greater standard deviation than the first set. And then if we go to this third set, this will be an even greater standard deviation. The numbers are jumping up by much more than they were jumping up in the previous set. So we know the greatest standard deviation here would be the third set, and we know the least standard deviation here would be the first set. Now, on the test, I would suggest not sitting here and calculating this out, since a question like this is generally constructed for you to use your intuitive understanding of standard deviation. But if you feel at all uncomfortable about simply eyeballing the set, then it would be okay to use the formula that we discussed to calculate the standard deviations. Now, sometimes GMAT questions will ask you to determine what happens when the values in a set change. In other words, if we have a certain set of numbers and double the numbers or increase them by a certain constant, the question will ask us what happens to the standard deviation. So if we take this set of the integers a, b, c, d, and e, let's say we add 5 to each of the terms. If we do so, we'll arrive at a new set of a plus 5, b plus 5, etc. Now, what will this do to the standard deviation? You may think that since we're increasing the value of all the terms, we'll therefore increase the standard deviation. But if you think about the situation, we're not changing the spacing. Whatever the spacing was originally, that's going to stay the same because the numbers are all jumping up by the same increment. So one rule we can derive from this is that when you add a constant to the terms in the set, the standard deviation will not change. Now, what if we multiply the terms in the set by a constant? What if we want to determine what happens to the standard deviation when we double each term? Well, if we double each term, we'll arrive at the set 2a, 2b, 2c, 2d, 2e. By doubling each term, we're going to double the spacing between the terms. Since we're doubling the spacing between the terms, the distance between the terms will increase, and therefore the standard deviation will increase. So what we know is that when you multiply the terms in a set by some value greater than 1, the standard deviation will increase. Now finally, what if we have each term? What will that do to the standard deviation? Well, if we have each term, we'll arrive at the set 1 half a, 1 half b, 1 half c, 1 half d, 1 half e. Now by having each term in the set, we're also going to have the distance between successive terms. If we're having the distances between the terms, then the overall distance from the mean is going to decrease, and the standard deviation will therefore decrease. So to summarize, standard deviation is used to describe the typical spread of the numbers in a set from the mean. To estimate a set's standard deviation, we will calculate the average distance of the set's items from the mean of the set.